All right, so ChatGPT 5.6 Sol and Gemini 3.6 Flash are both out right now, and the price gap between them is genuinely wild. Gemini 3.6 Flash costs 3.3 times less on input and 4 times less on output per million tokens. And that's not a rounding error. So I went through 5 third-party sources, no vendor spin, and ran these 2 head-to-head across 4 real tests: reasoning accuracy, latency API pricing, and context window handling. And every number you'll see is traced back to a source. Honestly, if you're running agentic workflows at scale, the model you pick could double your API bill overnight because of one surcharge you didn't see coming. And that answer is not what I expected when I started digging. This comparison is for developers and teams picking a model for production use right now, actual workflows where token costs compound and context limits break things. So if you're choosing between deep agentic power and high volume speed at a lower price, this is what you want to look at before you commit to a stack. Test 1, multi-step reasoning and coding accuracy. And when a model gets this wrong, your agent doesn't just give a bad answer, it goes off in the wrong direction for 10 steps before you notice. So you burn tokens, you burn time, and you're debugging an output that was broken from step 2. So I looked at the published benchmark data, and honestly, this one's messy. Gemini 3.6 Flash has a real number at 58.7% on Stawi Bench Pro and 49% on Deep SVE version 1.1, both community reported, while Sol has no published figure at all, just qualitative descriptions of strength in terminal commands and deep debugging, plus some flagged consistency issues around what press sources are calling cheating behavior in high-stakes tasks. Now, before you call this one for Gemini, take it with a grain of salt, because the fact that Sol has no published SWE bench score doesn't mean it performs worse. It just means OpenAI hasn't put out the number, and Gemini's 58.7% is community reported anyway, so we're kind of comparing a real number to a question mark, which isn't really a fair fight. I was expecting at least one model to pull ahead here, but the data just doesn't let you call it. So this one's a tie, the evidence isn't there to split them, and the score stays 0-0 with one test tie. Test 2, response latency and throughput speed. And the concrete problem here is that if you're running a high volume pipeline and your model is slow, requests back up, users notice, and your infrastructure costs spike before you've even found the bottleneck, because a model that turns a busy afternoon into a support ticket is a real production problem. What I found is that neither model has published hard latency numbers. No milliseconds per token, no tokens per second. So what we do have is Sol claiming a 54% token efficiency gain on agentic coding, and Gemini 3.6 Flash claiming 17% fewer output tokens versus 3.5 Flash. But those are against completely different baselines measuring different task types. You really can't stack them directly. The nuance here is really about positioning. Sol is explicitly flagged as a poor fit for latency-sensitive high-volume requests, which is just what it's built for, while Gemini 3.6 Flash is built for exactly those workloads. So they're not really competing in the same lane, which makes a head-to-head kind of pointless on this dimension. Honestly, I was expecting at least one hard latency number to show up, and neither model delivered one. So without comparable data, and with both models measuring efficiency gains against different baselines, there's no clean winner to call, another tie, and we're now at 0 for Sol, 0 for Gemini, 2 tests tied with the scoreboard still completely flat. Test 3 API pricing per token. And this is where things get real fast, because Sol has a long context surcharge that kicks in above 272,000 tokens and doubles your input cost for the entire request, which is exactly the kind of thing that blows a budget on a Tuesday morning. So I looked at the published API rates, and the gap is pretty hard to ignore. Sol runs $5 input and $30 output per million tokens, while Gemini 3.6 Flash is $1.50 input and $7.50 output, which puts Sol at 3.3 times more expensive on input and 4 times more expensive on output, and Sol's efficiency gains don't come close to closing a 4-to-1 price gap. I was expecting pricing to be close enough to call a wash, and it really isn't. So Gemini 3.6 Flash wins this one cleanly on raw API cost, and it's the only verified win in this whole comparison, putting the score at Sol 0, Gemini 1, 2 tests, still tied, because the price gap is just too wide for Sol's efficiency gains to cover on most workloads. Has test 4, context window, and long document handling. And the failure mode here is pretty specific, because you feed a model a long code base or a big document, it hits its context limit, and it starts dropping earlier chunks without telling you your output looks fine, but you only find out when something downstream breaks. What surprised me here is how one-sided the published data is. Sol has a confirmed 1.05 million token context window with 128,000 max output, cross-referenced across 2 independent sources, while Gemini 3.6 Flash has no published context window figure at all in the evidence I went through, and it's just a gap in what's publicly available right now. Sol having a published number doesn't automatically mean it wins this dimension, because Sol also has that long context surcharge above 272,000 tokens, where your input cost effectively doubles for the whole request. So you've got a bigger window, but a steeper price for using it. And Gemini might handle long documents just fine. We just don't have the spec to confirm it. I honestly thought Sol would take this one given that confirmed 1.05 million token window, but the missing Gemini spec means you can't score it. So this is another tie, and that brings us to Sol 0, Gemini 1. 3 tests tied across all 4 dimensions, which tells you something. Most of this comparison is still genuinely unsettled. Okay, so here's where Sol actually pulls ahead. If you're running deep agentic workflows, terminal commands, multi-tool coordination, sustained debugging sessions, Sol is built for that, and Gemini Flash isn't, and with a confirmed 1.05 million token context window plus 128,000 max output, that 54% token efficiency gain on agentic coding means it genuinely gets more done per session. Now, here's where Gemini 3.6 Flash wins outright. The pricing is way cheaper at $1.50 input and $7.50 output versus Sol's $5 and $30 per million tokens. That gap compounds fast. At scale, Gemini is built for latency-sensitive, high-volume workloads, which Sol is explicitly not recommended for. And it's the only model here with a published coding benchmark at 58.7% on Sawi Bench Pro going. And I was expecting a clearer overall winner, and what I actually got is a use case split. If you need deep agentic autonomy, multi-tool coordination, and a massive confirmed context window, go with Sol. Just watch that long context surcharge above 272,000 tokens. But if you need high volume throughput, latency-sensitive pipelines, or you're cost-constrained at scale, Gemini 3.6 Flash is the obvious pick because the model isn't the moat here, your workload is.